In this video, we discuss learning outcome number 4 for lesson 10.2, which is about outliers and influential points. My goal for you is that you'll be able to define outliers and influential points and to be able to determine whether you have an outlier when you are looking at a scatter plot. Now, if you have a scatter plot that includes the regression line with and without a point, I would like you to be able to determine if that particular point is an influential point. So here are the definitions. When we're referring to a scatter plot, an outlier is a point that lies far away from all of the other data points. So if you're looking at a scatter plot, it's really easy to see if a point is an outlier or not. Now, this is somewhat subjective. If you think it's pretty far away, someone else may not think it's very far away. So keep that in mind. There is more of a concrete definition of outlier. It's sort of a rule of thumb that some people use, but we're not going to discuss that much in this class. We're just going to say an outlier is a point that lies far away from all the other points. Now, if you're dealing with paired sample data, that paired sample data, may include one or more influential points. Now, these are points that strongly affect the graph of the regression line. So if you're trying to determine if a particular point is an influential point, you would have to graph the regression line on that scatter plot in two cases. You'd create the regression line on a scatter plot when you have the influential point included in your sample, and then you would come up with the regression line again, this time not including the potential influential point in your sample. If the regression line changes dramatically, that point is an influential point. Now, this is typically easiest to do if you have access to something like Excel that will allow you to quickly create scatter plots and graph regression lines. So here's an example. Let's say we're talking about the 23 pairs of chocolate consumption Nobel laureate rate data. The scatter plot to the left shows the regression line. Now, if we include the additional point 50, 0, we get a different regression line. So we're including this point 50, 0, which means you're talking about a country that consumes 50 kilograms of chocolate per capita, but they have no Nobel laureates per 10 million, or such a small number of Nobel laureates per 10 million, we're going to at least estimate that it's 0. The question is, is that point an influential point, or is it an outlier? Well, I think it's easy for all of us to see that it's an influential point. Look at the difference between this regression line and this regression line. It changes quite a bit, just including this point. So that means that that point 50, 0 is an influential point. So the graph of the regression line changed considerably by adding that point to the data set. Now, also look at this graph with the influential point included. All of the rest of the points are over here with chocolate consumption between approximately 0 and approximately something that looks like 12 kilograms of chocolate per capita. So that's sort of typical for our data set. To have a single point where you've got, or a single country where you have 50 kilograms per capita of chocolate consumed by that country, but then absolutely no Nobel laureates, or at least a Nobel laureate rate that is so small that we're calling it 0. That's definitely an outlier. And just looking at the graph, even if we didn't know what those numbers represented, we can see that all the rest of the points are over here, and this point is over here. So it is an influential point because it changes the regression line, but that point is also an outlier because it is lying far away from all of the other points. Now, I realize that the outlier one is a little bit subjective. So if we're over here, some students might say that even this point is an outlier. They might think that that looks like it's far away from all the others. And that's where it gets a little bit questionable. But I think in this graph on the right, it's very clear that this point at 50, 0 is very far away from all the other points. And we can also see that the equation of the line, or excuse me, the graph of the line itself changes dramatically. So in this graph, it's clear that 50, 0 is both an influential point and an outlier. In a graph like this, it would be a little bit harder to tell whether a point that was given in this set of 23 points is an influential point or an outlier. The only way for us to be certain that a point is an influential point is to graph the regression line and the scatter plot with and without that point, and to see how that line changes. That would require us to have access to Excel again. So that is the end of our discussion of outliers and influential points. I will see you in the next video to discuss the least squares property. We've been saying all this time that the regression line and the regression equation describe that best fit line, that line that best fits our data. You might say, what do you mean by best fit? How exactly do you measure that? Well, that's where the least squares property comes into play. We'll talk about that in learning outcome number 5. And I'll see you for that video next time.